We're going live. Just waiting for YouTube to warm up. There we go. Oops. It's yeah. There we go. Good morning. Good morning. It's Saturday morning. Yay! It is Saturday, isn't it? Yes, it is. Oh, am I ready? I think so. Let's get going then. Hello, and welcome to Practicalli. Thank you very much for joining me today on this glorious but chilly Saturday morning. The cats are fed, so they shouldn't disturb me today. Yeah, so welcome to Practicalli. My name is John Stevenson. Thank you very much for joining me. So today we're going to do some exercism. So last week we started looking at some exercism.io, which is a really nice online website. And I think the thing that makes it more different to other online challenges is that you can also get a mentor through the website as well. So if you are still very new to Clojure and you need some extra help, then you can submit your solutions to be reviewed, and somebody else will go and help you develop the solutions as well. Ooh, excuse me. Okay, let's have a look. Where are we now? Everything's working. Woohoo! Yay! So if you need to get in touch with me, or you want to look at some of the other content that we've done, then go to practicalli.github.io. I see all the video screencasts and the books I'm working on as well. I've been doing some more updates in the Practicalli Spacemacs book as well, so if you want to understand how to use a nice Clojure development environment based on Emacs, then this book should guide you through there. There's an awful lot of stuff I've added over the last week. I've changed a few things around as well, and it's pretty simple to start. I've updated the starting process, so you can just basically clone, install Emacs, clone Spacemacs, and then you can clone my configuration, and you can get a tool that's up and running. It supports Clojure, gives you lots of useful features for Clojure development, and it doesn't take any real effort or much time to actually do. So you just basically clone Spacemacs, and you can clone my particular spacemacs.d directory as well. And it should be up and running in 5 minutes, because it takes a few minutes to download all the packages from Melpa. Okay, that's the plug over for that book. And if you need to get in touch, then it's quickest way is via the Clojure in Slack community. And if you don't have an account, you can create one here. And if you want to keep me motivated, then there's 3 ways to kind of help there as well. So you can either subscribe to my videos and add some comments about what you want to see next as well. That's always useful. If you want to make a donation in a currency, then PayPal me, or you can sponsor me on GitHub as well, but that's just in US dollars. Okie dokie, advert over. Let's get to exercism. So I've already logged out. If you've never logged into here before, then you can sign up and create an account. I just log in with my GitHub account. It's pretty quick and simple. Well, first time you do that, obviously it's going to prompt you to authorize Exercism to connect to your GitHub account, but all it does is just read things from your GitHub account, so it's not going to change anything. And then with an account, then it's obviously tracking what you're actually doing. So I've done work on the Clojure track, and if you go to your profile, then it lists all the ones you've actually completed. Excuse me. And so today we're going to do at least these two bass song and humming, the ones I've done. I did them last night, so hopefully they should be fairly clear. And yeah, if we get a chance to do any other ones, then I'll do that as well. Most of the challenges, if you look on the Clojure track, they're all marked relatively easy. There's a few mediums. I think the bank account is marked as a medium, but I found that fairly easy. As long as you know as long as you understand atoms, then it's fairly easy. I guess the medium is because you need to know how to use an atom. And there's some other ones. I think there's only one hard one. It's like Go counting, so like counting the moves on a Go game board, I think. So we'll try and do a few more challenging ones in the future broadcasts. Okay, let's have a look at beer. We're going to start with beer song because it's fairly straightforward. I've got a very long solution in there, but it's basically walking through how I arrived at the solution. So at first it seems really simple. There's a little bit of string manipulation to do, but you basically got to write lyrics or generate lyrics for the beer song 99 bottles of beer on the wall. And you could you could have this 99 bottles of alcohol-free beer on the wall. You could have 99 bottles of something else on the wall if you wanted to as well. But to pass this exercise, obviously, we need to get the exact string returned. And so you can see that it's got a number that we're starting with, and then the second line of the verse is counting down, so it's -1. And we keep going down and down and down the values until we get to the end, which is a long way down. Oh yeah. So there's not much of a description here, but if you actually go and clone the project, which I did, so if you go to here, and so you can just launch is it Exercism download. Yeah, there you go. So you just you got the Exercism tool installed, and it just downloads all the projects for you. So I can just do that. I've already done that, so I'm not going to do it again. But it's basically downloading the exercise called Beer Song from the Clojure track, and then it's opening my editor. I'm going to make that bigger. There we go. Boom, boom. Okay, so so you start. Oh, ooh, excuse me. I think my voice has gone this morning. That's better. Okay, so we started off with there's just a namespace. I've added the require Clojure string because I'm going to use that later on. But you're starting with two functions. There's oops, there we go. I've broken it already. There we go. You start with two functions. There's the verse and there's a sing. So these two functions are given to you already. So this does show kind of a very common way to break some of your code up. So if you've got a very long function, if your function is taking up, I think there's a rule of thumb, if your function is taking up the whole of the page in your editor, then it can probably do with some refactoring. Or you're using a very complex loop and recur and you've probably missed some abstractions. So if you got, so rather than do everything in the sing function, we've got a verse function that basically returns each verse, and a verse is like 2 lines of the output. So a verse would be this would be so that how many bottles of beer on the wall are, and then the fact that you're taking one down and returning it. So that's those 2 lines make up a verse. There we go. Cool. Yeah, so we've got 2 functions split out, yeah, so we've got 2 functions split out, and we've got so verse, which is going to return the just a pair of lines that go together. Oops. And we've got sing, which is going to create the whole of the output. And that's, we can give that either a single argument or a double or two arguments. And so if we actually look at the tests, then it gives us more of a clue about what's going on. I usually find that looking at the tests in any kind of challenge thing actually usually helps clarify what the description is trying to explain. So here we got just normal require, and this is normal. Oh, excuse me, my voice is really going. There we go. Yeah, so we've got require here. So normally you put require in the square brackets when you want to define specific things that you want to require. So if you want to require as an alias, if you want as an alias, you need to put square brackets. Or if you just want to refer specific functions from that namespace, then you put in square brackets. If you just want to make it available, you can just put the name of the namespace you want to include. So here we're doing beer song, which is our namespace under test. So we don't have to put that in square brackets, we can use it like that. Although I kind of do tend to prefer sort of wrapping it. So if we do, oops, what's it doing? Oh, I did the wrong thing there. So it's around that. So you can do beer song, and then do like as software and tests. But then I'd need to go in and actually change all these where I'm actually. So beer song wouldn't be that. So here it's using beer song and then calling the name of the function. So we're still using the full path of that function. But if we use beer song software under test or system under test, then we could just replace beer song with SUT in there. But we'll just leave it as it is for now. So we've got a bunch of defs defining these strings. So basically they're defining the verses. So this is kind of the expected output that we want to have, because if we look, this is verse 8, verse 2, verse 1, verse 0. Then we can look here, and then it's comparing these defs that we have with the results of calling beer song with verse 8 and verse 2 and so on and so on. So this is just basically setting up, this is our setup data for our tests, and this just means it makes the tests a lot easier to read. It's not full of big long strings, so that's quite useful in that way. So we're testing the individual verses, but we're also testing songs as well. So a song is a collection of verses. If we look at the song, then a song is just a one long string that has some slash ends, some new lines in there, and this means that we can notice that on some lines it's got 2 new lines, and on some others it's got 1, which ties up to the verse here, because we've got an extra new line between each verse in the song. So we need to include that as well, but not on the end and not on the in between the verses as well. So that's just adds a little bit of fiddliness to the whole thing. And let's see. So if we go, we go back to here's my REPL running. Oh, it is. There we go. So I've got my REPL running. So if I leave it these, then I can go in and run the tests. Oops, no. And you can see they're all failing at the moment because I haven't actually generated any output yet. So there's nothing up my sleeve. So the first thought I had was like some kind of filter, I think. did a cond. Oh no, I did a cond. Yeah, so I looked at this. Well, how do I generate the? I'm thinking of Hamming. Sorry. Yeah, so I looked at the verse. I thought, well, how do I generate the verses? And if you look at the verses, then you can see there are subtle differences. There is no kind of one way to kind of do it. I mean, you can do most of these ones down to 0, or down to 1 that are the same. But if we look at the tests, you can see a lot easier here. So here we're just doing 8 bottles of beer on the wall, and then we get 7 bottles of beer. But if we do verse 2, it's still 2 bottles of beer. But when we do that, it's take one down, pass it around. There's 1 bottle of beer, so that's singular rather than plural. So that's one thing that we have to take care of. And when we got verse 0, then it's got no more bottles of beer on the wall rather than a number. And verse 0 also has go to the store and buy some more bottles of beer on the wall, but not necessarily when there's a virus going around. So there's at least, say, 4 different kind of subtly different but different enough verses that we need to generate. So I decided to use a cond. It's a bit like a case statement. So it's a conditional. So based on a condition, if the condition is true, then we do that particular expression. So if the number equals 0, then we do this expression. And I've just grouped the condition and the expression it's related to on separate lines, just because the this expression is quite long, and I've just put a space in between them as well. So it kind of just helps organise the code a little bit. I think it makes it a bit more readable for me. So def verse, it takes num, and then it's and then we just run it through, and whichever of these matches it's going to do, and it's going to skip all the other ones. So if it's 0 or 1, it's going to generate the relative things, and if it's anything else, I think this is before I noticed that verse 2 was different as well. So for most of them, it's going to do this one. It's going to take the number and add that to the string at the start, and put it in again in the second place, and then it's going to decrement the number in the second line, and there we go. So that's a fairly easy case, and they both got just a single n behind it. I did have an extra new line here, but then you have an extra one when you generate the whole song, so I've just left that individually and fix that later on in the whole song. And so number 1 has no more bottles, and number 0 has go to the bottles and beer. So we still need to add 1 for the second condition, but this works okay. This generates the verses that we want. Oops. So it'll generate a verse, it'll generate the so that matches at least some of the tests that we have. So the individual verses, like verse 8, I think that works correctly for that. So how do we actually generate the whole thing? Well, it's basically a sequence of numbers. So we're counting down from 9 to counting down from 99 to 0, and so we can generate range from that as well. It's very easy to generate a range of numbers. We can specify the start and end points, and if we define the start and end point, and the end point is lower, then it's not going to generate anything, but because by default it's going to have an increment of 1. So you can see in this example we're always incrementing by 1. But if you give it a third argument, then it's going to step by that. So if we do an argument of -1, then we can get it to count down. Whee! So we get our numbers, And you can see that so we're going from a range 100 to 0, but the endpoint is always exclusive, so it never actually counts that last number. So you can see that there's no 0 in there. It only goes down to 1. Then we come to 0 and say, okay, well, we've reached the endpoint, I'm not going to do any more, so it doesn't add the 0. And so yeah, and now -1 is just our step. So if we want to have well, if we want to have 99 to 0, shouldn't really be 100, should it? It should be 99. Oops. 99. Oops, I didn't want to do that. My editor's being too helpful. So we got 99 down to 0. So that's how we do that one. Yeah, so that's easy. So if we've got a range of numbers, then all we need to do is map over the verse over this sequence of numbers, and hopefully it generates something very close to what we need. Because each time it gets a number, it passes it to verse, then verse knows what to do with it. It generates the relative center, the relative string from matching the condition. And then we'll do boom. Wrong one. What's it doing? Come on. So many keys on the keyboard. Why is it not working this morning? Oh, wrong button. That's if you press the right button. There we go. I'm just using the reader macro comment here. So anything that starts with a hash is a reader macro. So it's read in, and Clojure does something to the code before you actually pass it to the evaluation. In this case, it's just going to treat this next expression as a comment. So basically it's the same as doing a colon, except its scope is the expression rather than the line. So if you're using a colon, I usually use a double colon as a convention. It's going to comment out the whole line. But if you do hash underscore, it's going to comment out the next expression. So even if that expression is on 2 lines, it's still, that whole expression is still commented out. So I find it quite convenient, because then I only have to do the hash underscore at the start, and it's commenting out this whole expression. Ooh. There we go. So we've got verse. Let's have a look at verse for a second. There we go. Oh no, we've done verse, haven't we? There we go. Oh yeah, so verse. Yeah, I needed to fix the condition for 2, so I just added an extra condition here, so that it's because it's the singular bottle that's here and not bottles that's in the more generic form as well. And we don't need to dec because it's just specific. We're just hard coding all the numbers here because we don't need to do anything with them. So that works. So this generates the the function here. We can see it's generating our results, but it's putting them in a sequence of strings. So we've got here, if we just put in the oh okay, oh that's not quite right, is it? So yeah, so that instead of being one big string, which we need, we've actually got a list of strings. So we need to fix that at the moment, because in the results in the test case we've got to return a single string. So strut is going to tie all these together into one string, and that's what it's going to look for. What do we do? Yeah, so we can, but it works. I mean, it's kind of like the basics are there. It's generating our strings. It's going from 3 bottles down to no more bottles of beer. Down here, no more bottles of beer. So it's doing the right thing. We just need to change the format, the final format a little bit. And same with sing, we can also pass 8 and 6. And I now realised I didn't actually cover what we did for sing, did we? Oh, okay, yes. Yeah, we didn't cover what we did for sing. Oops. So, yeah, so sing, we've got a map. We're just mapping verse over our range. So we're taking the number that we pass in, start, which is the starting number. So if we just call verse 8, it's going to do from 8 to 0. So it's going to do from 8 down to 0, or -1 in this case, so that includes 0. And so that generates us, and that's generating our sequence of strings, our list of strings. And if we press the start and end one, then we can just do range from the start, and then we just, because the end value is going to be exclusive when we use range, then we just need to decrement the end value by 1. So if we passed here 8 to 6, then it would we'd have a range from 8 to 5, and that would generate the numbers from 8 to 6 in a step of -1. We're going to refactor this a little bit later on, but for now it kind of does the basics of what we need to do. So 8 and 6, you can see it's just generating from 8, and then it stops at 6, although we still, 5 is the last number. So that works, but we've still got it in a list, and one of the other things I needed to fix was having the extra new line in between the verses as well. So those two things we need to fix. So we did string here, and what do we do here? Oh, I don't think this has changed, is it? This is the same. Oh yes, sorry, yeah. So what I did, it's such a little change, I didn't spot that. So to get this from being a list into a string, then we basically just apply string to the results of the mapping function, and this is just like putting str. It's like putting str in here. So therefore, it calls str as a function with all the strings as an argument, and then we obviously get a single string back in return. So that fixes the list problem that we had. And because we've got a polymorphic function, and it's doing very, very similar things. I mean, it's not really doing anything massively different. It's only the range that we're using that's different. We can actually just minimize code and make it more generic by actually just getting the single function branch of this function to call the multiple, so the 2 argument branch. So this is what I've done. So instead of calling map specifically here, then I'm calling sing again. I'm calling itself, but I'm giving it 2 arguments. I'm giving it the starting value, which we've already got from when we called the single argument branch, and then I'm passing in -1 as the endpoint, because that's what we were using up here as well. And then, yeah, that's it. And so therefore now we don't need to have 2 applies. We don't need to put apply on here, because our apply string is going to be put onto the results of this, and the endpoint is now going to be -1. So it's kind of it's simplifying our sing expression quite a lot. There we go. And it's quite common to see this in polymorphic functions, where you've got where you can call it with different numbers of arguments. So we can call sing with a single argument and 2 arguments, and the single argument calls the one with 2 arguments. And usually with some kind of default value. In this case, the default value is going to be -1, which generates down to 0. I hope that all makes sense. Nobody's asking questions, so it must be crystal clear. And this one did trip me up briefly. The fact that there's a new extra line between each verse, which I didn't spot straight away. So how do I deal with that? Well, I tried to use interpose, but that puts it doesn't quite work. We still need to do the apply string on top of that as well. So I did think about whether we needed to use something else that did interpose and apply the string at the same time. And this is where I went to add the clojure string thing, so we could use join. And so we use join as an interpose, like a combination of interpose and apply string. So if we put apply string around this as another function, put it in there, then it would give us the result. But then we've got a lot more calls, so we can keep our code fairly clean by just using something that does both of those. So we join, and we're going to join all the strings together, and in between each string that we're joining, we're putting in a new line as a character. So if you wanted to convert, if you had like a string of list of strings, and you wanted to convert that to a comma separated value list, it's kind of like output, then you could use clojure string join with a comma around that. Oops, I didn't want to do it. Oh, REPL. So you do clojure dot string slash join, and you could do a comma, and that would create a comma separated list. What's it complaining for? Insufficient input. Oh, it might need to do that. There we go. Oh, there we go. I like my linter. Thank you, Bog Dude. And so now we get a string that's a comma separated list, and you can see that it's only putting it in between the characters. It's not putting it at the start and end. So it is doing the interpose, but it's also giving us a single string as a result at the end, which is nice. And because we've got, I think, I got the, because we always deck. So I realised I'm producing too many things, because I've got -1 here, but then we're also decrementing that as well. So I changed that to 0 and it fixed it. So now we're joining all the strings together with n, and the singles, because the single argument version is calling the 2 argument version, then we don't need to do anything else. We just fix that 2 argument version, and we're done. And I believe that's that is the one that I used. So evaluate that one, go back to, where was it? Oh, there we go. And then back to my verse, evaluate that one, and then I can jump into my tests. And if I've done everything right, they should all pass. Yay! Down the bottom we've got, there's a little green bar down the bottom that shows me that I've passed all my tests. There's a test report, OB, there we go. Yeah, so there we show all my tests are passed. Boom. Cool. Okay. And so then I just submitted that one, and it all worked. So that's that one. It's fairly straightforward. I think it's a nice way to practice the creating and working with polymorphic functions. These are quite common. If you look at the Clojure core, you'll see quite a lot of polymorphic functions that have got different branches of code based on the number of arguments you're given. You can't do polymorphism so easily with based on types, but there's things like def records. You can do def records and def multi methods around that if you want to call different branches of functions based on the type of something. So you can define your own types with def records, but most of the time you don't really need to. Okay, nobody's got any questions, so I'm going to leave that one as it is. I'm just going to shut down my REPL because I don't know how many REPLs I've got running. There we go. I don't know what I did there. There we go. Okay, and so the next one is, where did we get to? Oh, hamming. So we did that one. So that's all there, and we did hamming, which is, if we look at the instructions, so in summary, basically, if we've got two strings that are representing like a DNA sequence, then we want to compare them and see how many different things there are. So here we've got C and G are different, A is the same. So basically, wherever you see this mark, then we can see that there are differences. If we count up all the differences, 1, 2, 3, 4, 5, 6, 7. So this has got a Hamming distance, which is a well-known term apparently. It's got a Hamming distance of 7 because there are 7 differences into the between these two strings. So it's a relatively, well, it sounded relatively simple. It's not that difficult once you get the right answer. I mean, the answer is fairly straightforward, but there's a few different approaches I think I took, yeah, so we'll walk through those next. And one important thing I didn't notice at the start was like it's for sequences of equal length. So if the sequences are of a different length, then you can't calculate the Hamming distance. So this is kind of assuming that if you've got two sequences, two strings that have different numbers of characters in them, then you're just going to return like a nil value because it's not the correct. You can't generate a Hamming distance from that because the data is corrupt. The data is not correct. So I guess that's our basic exception handling there. Okay, so we go to our editor and open up. Do I already have these open? No, I don't. Hamming, there we go. Let's open up our test. Oh, there we go. Boom, boom, boom. And that's all our code. So to start with, then we were just given, oops, I'll make this a little bit bigger. Oops, I missed. There we go. Yeah, so we were just given this to start with. Make that a bit bigger. Wow, much bigger. There we go. So we've got a function called distance. It takes 2 arguments, and we need to write some comparison for it. If we have a look at the tests, bigger, then what we've got here is, so we're including test, we're including Hamming, and we've got several functions that is just basically calling Hamming distance. So we've only got one function to call, and it's passing in here. We've got 2 empty strings which should give a distance of 0, same for 2 identical strings. These things are completely different, so they've got a Hamming distance of 3. This has just got 1 difference in there, so I think it's the A and the T are different. And then we've got 2, it's got 2 different changes, and then we've got 2 ones that are different lengths of string, so we want to be able to handle that, and in this case it's just returning nil. So it seemed fairly straightforward. So my first thought was to use filter, although this didn't quite work because I forgot filter only takes 1 collection, as my linter is obviously telling me, and I've got too many arguments. So like the lint is really handy because it's kind of a little voice that tells you, oh, you've done something that's not quite right. You should fix that. And once I noticed it, then yes, I started changing it. So I can't do this because I can't. If I take 2 arguments, it's not going to take them across 2. It's going to take them from 1, and it's not going to have any values for the first argument. So it doesn't quite work there. But basically, what I was trying to do is run a function across 2 collections and compare each value as we iterate through those collections. Compare each value together and see if they're the same, and if they are, then we're going to keep that value, and then we can just add how many values we've got up, and we've got our Hamming distance. Although that probably should be not equals, really, but it doesn't work anyway. So we can only work with 1 filter structure. Same for reduce as well, unless you have a reducing function that works over 2. And I tried compare, but compare isn't quite the same as I want to do. It's a really interesting function. If we go to Clojure compare on the Clojure docs. So if we can compare 2 vectors together. We can compare a lot of things. We can compare 2 strings, and you see here they're very different. So we've got -3, so we could kind of invert that, and we get the right answer, because we've got a Hamming distance of 3 there, and a Hamming distance of 1. But when I tried to do this on some of the tests, we were getting some very weird numbers. I couldn't quite work out. So it was doing things that, so we go, oh yeah, it's kind of cumulatively adding how far away they are. So here we're comparing A and Z, and we get a -25. So it's not just comparing the fact that they're different, but it's giving you the distance they are away from each other as well, which is beyond the scope of what we wanted to do for this challenge. Although I could imagine somebody doing a very similar challenge where you say, well, how far away is between A and Z? And compare would be very, very useful for that. So that was a new function. I hadn't come across that one before, so it was quite nice to just be aware of that. And then what did we do? Oh yeah, and then we just went back to basics. So I did put in a condition here, so we're just checking to see whether the 2 strings are the same length. So I'm just doing a count on each of the strings, and I get a value back, and just then comparing the value for each, because count is just treating a string as a collection of characters. So it just adds up the number of characters that are in there, and we get a result. And so if they're equal, so if the strings are the same length, then I'm going to do the compare, which didn't quite work, but well, it passes the last test, because it will do nil if the strings are not the same length. And so then, well, so all I needed to really do is just fix this line, and it kind of works. So rather than using compare, I thought, well, if we've got multiple collections, how do we work with multiple collections? An obvious choice is, or starting choice is usually map. If we're doing things down to the basic level. There we go. So if we map a function over 2 strings, we've got our 2 strings that we pulled from our tests. If we map a function, we just write a function ourselves. So it's just an anonymous function we've written, and it's going to take 2 arguments. So this is the A is going to be the characters from the first collection, and B are the characters from the second collection. So this is going to go iterate through both of these. Because they're the same length, then it's going to work, and it's going to give us a 0 if they're equal, and a 1 if they're different. So this basically gives us 1s where there are a difference, so we can then just add the number of 1s together, and we get our Hamming distance. So we do that. Obviously, if they're the same string, then we just get a list of zeros. And if we add all those up, then we get 0. So we know that they're the same. And if we do the same thing with the difference, then we can see here we've got a difference. And so if we add all the 1s and zeros up, then we get 1. And we get our difference there. Yeah, so we just, if we do apply plus, because it's these are returning a collection, then we need to apply plus, so it's just like putting a plus sign inside the collection, and that gives us our single value. Oh, there we go. So this has just got a single change between them, so the C and the G are different. So then we can put that into our function. Oops, too many. And yeah, so this works. This kind of does, I think it works. Oh yeah, I've redivided it several times. This is just complaining I've got several definitions of distance already. But if we evaluate that one, then when I run the tests, it's only going to run that one. So if we do comma test all, so it works. All green, all my tests are passed. There's no errors there, that's good. But we can refactor this a little bit and make it a little bit nicer. We can use the short form syntax definition for this function. And this is probably where this is a useful example to show where we're using the shorthand syntax for a function definition, anonymous function, is probably preferable. So here we're doing, instead of, oops, yeah, let's see if we can get them on the same line. There we go. So instead of having the map, so we've changed the map expression down to just using the hash. So it basically strips away the function side of things, so we don't need to define the function or the number of arguments it's passing. We can just do the hash to represent that. So again, this is just a reader macro, so this is just going to expand this expression into the function definition that's in the example above, and it's just doing equals instead of A and B, because A and B don't really mean anything. We don't actually have to name our local names, the local symbols we're using to bind the values together. We can just use %1, %2, and percent is just the same as %1. So we take the argument from, so %1 is the arguments in turn from strand 1, and %2 is the arguments from strand 2. And then we return either 0 if it's true, if they are equal, or 1 if it's not true, if they're not equal. And then we can we're still returning nil there. But we're not really doing anything with this if branch. So if we're doing, if we have a branch, if we have an if, and we've only got the true branch in there, and we're not calling the true branch, then it's going to return nil by default, because all functions need to return a value. So if the true, in this case, if the true path is not matched by the condition, so 1 does not equal 2, then it's not going to, I suppose that should be equal, shouldn't it? There we go. Then it's going to return nil, because it's actually calling the next thing, it's skipping over equals, and there's nothing to return, so it returns nil. So if you've got an if like that, I think that is exactly what my missing else branch. So it's saying missing else branch. It could also suggest that I use a when. If you're using tools like kbit, it would actually tell you to use a when rather than an if. So that's what I did. I've just put a when instead in here. So instead of this if statement here, instead of the outer if, I just put a when. So when the strings are the same, then we do this, and if they're not the same length, then just return nil. Luckily, that's what our tests expect us to return. And so then we've got a fairly nice, clean, almost a single line function. Again, you can put this on multiple lines if you want to. Depends how you want to organize it. But this is kind of more the idiomatic closure of having a when for a single branch, and using the shorthand syntax for an anonymous function. Oh yeah, and then so that's also works. If we do that one and go back to the tests, so they're still working. Woohoo! It's nice to have tests that tell you everything's working. There we go. And so then, but is there any other ways we can do this? So instead of doing this, is still kind of very explicit. Probably do something a little bit more abstract around the this condition we're doing. So if we use not equals, it's kind of the same as this. So if we do map not equals over here, then we're getting instead of zeros and ones, we're getting true and false, which is kind of the same. I mean, if we're using 0 and 1 in the above example as a sort of a binary differentiator anyway, so that may as well be Boolean. And so then we've got a false, true, false, because we've got the B and the O in the second character of each string is not equal, so that's true. And then if we filter that result, so if we got this false, true, false, if we filter that, it's going to basically drop the any of the values that are equal to nil, which is usually nil or false. Usually everything else in Clojure is truthy, whereas nil and false are false or falsy. So there's this is identity function, which basically returns something. If something's true, it's just going to return. If something's truthy, it's just going to return that value. So I did identity over 1. Then it's just going to return. Oh, I didn't start my REPL. There we go. Whoops. Why not? Oh, it did. There we go. So it's just going to return 1. So that seems to be kind of pointless. But when you run when you filter by identity, then it's going to filter out all those false values that we got from here, and it's just going to return true. There we go. So we're filtering out all the things that are false by using identity. Oops, I didn't want to do that. What did I do? Oh, true. Oh. There we go. And count. And then we can just, if we're identifying true for every character that's different, then we just count up the number of trues that we got. And then so we've made something that is possibly a little bit more abstract. It looks and feels a little bit more abstract than the previous example we had here. Just because we're using standard Clojure core functions. We're not writing any of our own functions, which is usually preferable because then we don't have to maintain anything. Yeah, so we've got the same when expression, and then this time we've just got count. We're counting the number of trues we get by filtering identity on the map where the characters are not equal from those two collections. And that still works, he says, with the question mark. Yay, it still works. There we go. So identity is a bit of a strange one, I think, to get used to, but it is quite handy. It's quite niche, I guess, but it's quite handy in certain situations. So I did identify a few other things just by looking at the docs. We can use identity to flatten a nested collection. So we've got a vector that contains two vectors, and inside each of those vectors there are more vectors, and there's another vector as well. So if we evaluate this, then we're actually just flattening that structure, so we get a collection of just the vectors, because the identity of each of these things is going to be the innermost data structure, the innermost vector. So that's a value, and that's a value. Because I think, is that the case that if we do, oops, I didn't check this, but if we do identity, helps if I spell it right, on a vector, does that return nothing? Oh, it returns an, okay, it returns an empty vector. Okay. So this is basically going through and now saying what's the identity of all these things, and so it's picking up that as an identity, as a value, that as a value, and that as a value, and then it's just returning them in the default collection, which is a list. So we basically have flattened that data structure. So it's a nice way to do that, and it's a pretty clear what it's doing, I think, in terms of getting specific values out of a nested data structure. So it's possibly a little bit less of a blunt tool compared to, because there's flatten, but flatten is a bit of a blunt tool, where at least here you can kind of see more clearly what it's going to do. And another example of identity was when you're doing things like or and, but you have to do those over a collection. So one of the things I did come up with, one challenge was I had basically an and I had a true, true, false, true. It's something like that. So I generated the results of I generated something which basically returned a sequence of true and false values, and I wanted to see whether they were, if all of those were true. So if they were all true, then and would return true. But if one of them was false, then obviously we get false. But in order to do that, we can't do that because because and is just comparing the whole sequence, the whole list, but it's got nothing to and it with, so it just returns that value. So we need to do something like apply, which would put the and, essentially would put the and in here, and so then we give it the individual values. Because we do, so we basically want and true. So if they're not equal, we get false. Oops. True D. True dat. True dat isn't a clojure function. Maybe I should write a macro to do true dat. No. But if they're both true, then we can return true. But if we apply, then we get a nice little message reminding us that yeah, we can't use a macro function with apply. We can't pass a macro. So this is one of the limitations of using macros. If you're defining a macro but then you realize you have to apply that over a collection, it's not going to work. So one way to get around that is to use identity. So you can achieve the same results as and by using identity, and so we're checking to see whether everything in the collection is truthy. So we can see that, yeah, they're all true. Everything is true, and if something is false, then obviously every one isn't true, so we return false. And and we're working that over a collection. We don't need to worry about using a macro over a collection, and we worked our way around the problem. So it does have some really nice little handy uses. Identity. I think one of the foreclosure ones uses identity as well to make the solution very easy to solve. Oh, it's 12 o'clock. It's dinner time, lunchtime. Well, if there's no more questions, I'm going to leave it there. We didn't get more time to do any others, but there's plenty more to choose from on the Clojure track. And I want to try and hopefully I'm going to try and find some time to do some projects. I've got quite a few project ideas. I've gone to my blog, Practicalli blog. Then I've got in the contribution side of things, I've got where is it? It's yeah, I've got a whole bunch of issues in here, ideas about what to work on. So there's quite a few different ideas about like creating a static site generator, doing some web scraping in Clojure as well. So there's a bunch of ideas in here. If you want me to do any of those, then feel free to go and put some comments on that, put some thumbs up, and I shall read blogs. So I'll either write an article on it or also do it as a study group as well. So let me know if there's anything there that you really want to see, and I shall endeavour to try and do that. And you can also again reach out to me via Clojure in Slack and on the Practicalli channel, or send me a direct message as well, and let me know what kind of things you want me to do. Alrighty, I'm going to leave it there. Thank you very much for joining me again. It's much appreciated. It does make me keep me motivated to see people actually watching these screencasts, especially live. So thanks again, and hope you have a great weekend, and see you next week. Thank you. Bye bye.